Hello, my name is Mayank Rasu, and I'm a student of the MFE program of the WorldQuant University. I will be taking you through the presentation that I prepared as part of my capstone project. But before that, I need to establish my identity. So this is the government issued ID card issued by Government of India, which has my name and address. I hope that suffices. This presentation is about exploring the effectiveness of some machine learning algorithms in trying to improve the performance of momentum-based intraday trading strategies. As an intraday trader myself, I have felt that the screening methodologies used by most intraday traders is not really up to the mark. What intraday traders do is that they use various technical indicators in order to get signals and then trade based on their momentum strategies, which is a very fairly popular way for traders. Uh, but it's just that because of logistical reasons, you cannot follow the entire universe of stocks for the whole day. So the traders need to screen like 5 to 10 stocks at the beginning of the trading session, which they will then follow for the rest of the trading day, and then enter or exit the positions as per the signals. So for the success of day trading, it's very important to have like a good screening methodologies for the stocks that you will be following for the rest of the day. So the existing screening methodologies include news analysis, previous days top gainers and losers, and then pre-market movers. Sometimes it can even be driven by gut feeling, like some day trader may have a particular liking for some stocks, or he may have a hunch that these stocks, some stocks may go up or some stocks may go down. So again, this methodology of screening varies from traders to traders, and based on my experience, I think there's a lot of scope in which we can use artificial intelligence and machine learning to make the screening process smarter and help to generate positive alpha. So this project would try to explore the same thing. I have tried to explore the suitability of ML algorithms using pre-market data features to screen the stocks. The scope of this project is limited to Indian stocks, and within the Indian stocks universe, I'm only looking at the stocks which are used for futures and options, which is around 200, 203 odd stocks listed on the National Stock Exchange. So before this, I'll just show like a sample day trader screen. This would be a sample day trader screen that will be on in the front at the beginning of the trading session. So you see, I have set technical indicators as MACD, OBV, and ADX, and then I'll be looking for the signals and then enter and exit the position. Let me get back to my presentation. Yeah. So the hypothesis is that the pre-market moves impact a stock's day return. This is the prime hypothesis that I will try to prove using data analysis and other algorithms that I have created. And the second hypothesis is that the ML models trained using pre-market data can predict hot stocks with reasonable accuracy. Uh, so I just showed you a typical day trader screen. Below is the National Stock Exchange's website, and what they do is that they make pre-open market data available. I'll just show what it looks like. So and what NSE does is that it makes the pre-market stock movement like available every day. But let me first explain what is pre-open market. So at 9 a.m., if you open this page, you will see that this page is being updated in real time. You will see the stock tickers here. Sorry, this is Nifty. I am interested in FNO stocks. So you will see that these stocks are changing. The values are changing from 9 to 9:15. So the actual markets open at 9:15, but NSE allows a 15-minute window wherein mostly institutional investors trade by giving and taking positions. So it gives a good signal about which stocks are in play for that particular day. So obviously, if you are seeing a lot of movement for stocks in the pre-market opens session, then day traders typically they start. I mean, they typically follow some of the big movers for the rest of the day. So in my day trading, I have used this strategy. So I just thought of applying machine learning and seeing whether the machine learning applied screening methodology can can do better than the existing screening methodologies that people or typically day traders use. So in a nutshell, that's the objective that we will be trying to achieve through this project. So this is the design of my project. So the first step was to gather data. So I need two categories of data. One is the 5-minute OHLCV candle data, um, like the historical data for us to test our strategies. Uh, I could have gone for 15 minutes or 30 minutes candles as well, but it's just a personal choice. So I typically trade on a 5-minute candle window. So that's why I have gone with 5 minute. But I don't think using a 15-minute or 30-minute candles would impact the finding of this analysis. Then the historical pre-market open data. So the pre-market open panel that I just showed you, NSC refreshed it every day. In order to test my hypothesis, I have extracted pre-market open data for corresponding to the historical data that I have, so that I can check. Uh, I can go back in history and check whether the hypothesis is working or not. So these two are the primary sources of data that I need in order to build my project design and carry on with my analysis. Second step is stock screening. So in this step, I I have used existing stock screening methodologies that I had used till now before actually learning machine learning uh, through my association with WorldQuant University. So I have used the same stock screening methodologies that I was using before and mimic day trading using the technical indicators that we have discussed, and then get signals and then trade based on that. The third step is benchmark creation. So after the stock screening and mimicking day trading, we can calculate the PNL that those particular day trading strategies yielded, and then calculate the KPIs for those benchmark levels, right? And then the last step is the machine learning data preparation step, wherein I have so going back in history, I have identified which are the good or the bad stocks uh, on each particular day. So I have defined good stock as any stock which has yielded more than 1% using the same technique, same momentum based strategies that I have been using. And bad stocks are the stocks that are less than 1%. And then so this is my dependent variables, and independent variables were derived using the pre-market open data that I had just showed, the NSE pre-market open features. I'll explain which are the features that I used as independent variables for the machine learning data. Then this machine learning data, then this data was fed into my algorithms. So I have used random forest and KNN algorithms. The choice of these two algorithms was mostly because they are classifiers, and since this is a classifier-based problem, whether so it's yes or a no kind of a problem, whether the stock is good or not. So that's why I was not looking at regressors, but only classifiers. In addition, The RF and KNN models are not, they do not get biased because of the lopsided nature of the data. So since in my case the data is heavily lopsided, wherein you have like 5 to 10%, only 5 to 10% of the stocks are good, are hot stocks, and rest are not. So you so if we use some any other algorithms, we'll need to resample the data, which I didn't really want because my data was limited. So that's why I went with RF and KNN models. We also performed some hyperparameter and parameter optimization for these algorithms, and then based on the trained models, the the screen stocks were predicted using those strategies and the predicted stocks. I calculated the performance of the strategy and then calculated the KPIs with the earlier benchmark that we have created, and then compared these two to see how whether the ML algorithm based screening added any value or not. So in a nutshell, this is my project design. So this is the data gathering step. As I've already discussed, I got the 5-minute OHLCV data. I got this data from upstock.com API. This is a paid subscription, but since I am a subscriber, I was able to access data. The only problem was that they give only 4 months of data when you are looking for 5-minute granularity. So that's one of the limitations that I have discussed later. But yeah, so I was able to get 4 months of 5-minute OHLCV candles, which I used to train my data set. And then for pre-market open data, I used a web crawling script from howutrade.in. So this website actually saves the NSE pre-market open data every day and makes it available through a CSV. So I used a web scraping methodology to extract this data. So if you can see, I saved the OHLCV data in form of for dictionary, wherein the key corresponds to the stock and the value is a data frame with the OHLCV values for that particular stock for the 4 months duration. This and then the pre-market open was saved in as a data frame, which you can see in the below diagram. So data gathering, I would say data gathering was a fairly challenging step of this project because A, getting intraday data is not easy, and B, there were several data integrity issues. So I had to do a lot of work to get around the invalid data or missing data. So it was quite a challenging work to get the data in order for this project. And I've explained the data munging and gathering and cleaning process in my project report. So the next step was stock screening and benchmark creation. So based on like I showed the pre-market open parameters. I have chosen typically historically I have used two parameters from that pre-market open data. One is the highest absolute percentage change. So what I do is that I sort the stocks based on the highest absolute percentage change during the pre-market open session, and then I pick the top 5 or top 6 movers. I mean, it looks like a pretty intuitive thing to do because the assumption is that the more a stock moves in pre-market, the more, like, the more volatility it will see during the rest of the day. So this one is fairly intuitive, taking the highest absolute percentage change in stock value during the pre-market trading. The second screening methodology was the largest traded value, which is nothing but the product of the volume of stocks traded times the price. So this is also an intuitive. This also makes intuitive sense to use as a screener because it tells you which stocks showed which stocks saw the most action during the pre-market uh, open session. So this is also a fairly good indicator. So yeah, so then I ran it through the day trading function that I created and the KPI function that I created, and these are the KPIs that I got for both these screening methodologies. Uh, like you can see, both of them performed fairly poorly. So the CAGR of 7.3% and a CAGR of 22%, which is obviously not good. And the drawdown was also like fairly significant, which is also evident from the equity curve here. But based on these two, the traded value screen was slightly better. So I have used traded value screen as the benchmark, and I will be testing. I'll be comparing the machine learning. I'll be comparing the machine learning's KPIs with the traded value screens KPIs. I would also like to just point out here that the trading strategies that I have used is takes into account the MACD, RSI, the OBV, the on balance volume, and ADX. I have not discussed my strategy in the slide because this project is strategy agnostic. I don't think that changing the strategy would have any significant impact on checking whether the machine learning based screener is working or not. But it's just that just for the sake of explanation, I'm just mentioning that these are the four indicators that I have used as part of my technical trading strategies, and I've explained this in my project report as well. But this is the yeah, so this is the KPIs that I got based on that particular momentum based strategies for the two existing screening methodologies that I've been using. So obviously there is a problem, and I needed machine learning algorithm to see if I can do a better job of screening. So this is the interesting part. So now so now I tried machine learning algorithms to see whether the screening can whether I can do a better job of screening the stocks based on the pre-market open data. So like I said, 1% was the threshold that I had created. So I went back in time, and for every single day, I ran all the stocks through my trading strategies and calculated the return that each stock gave, right? And then I stored the stocks that had a more than 1% return. So, for example, if you see for 1st of August 2018, um, I had 10 stocks that yielded more than 1% based on the momentum trading strategy that I've been using. And these are Reliance, Bajaj, PNB, Bajaj Auto, IDBI, and etc. So this would be my dependent variable. So these 10 stocks would be labeled as good stocks, and other 190 odd stocks would be labeled as bad stocks. And this would be the dependent variable of my data. The independent variables were like these were created based on the variables that are part of the pre-market open data pre-market open data set that I've saved. So uh, I have taken the yearly high by yearly low as one independent feature, traded value by market capitalization as second feature, and absolute pre-market return as the third feature. So yearly high by yearly low, I mean, I took it because it's a rough estimate of how volatile a stock has been over the years, over the long term. So I thought that day traders might like to, might this may have some influence on the short-term volatility of a stock. So I took the yearly high by yearly low as one of the independent variables. Then traded value by market capitalization is a no-brainer. If you have a very high traded value by market cap, that means the stock has seen a lot of action in the pre-market open session, and you want to see, and you would guess that you would, yeah, you would bet that this may have an influence on how the stock moves for the rest of the day. And the third is the absolute pre-market return, which I've already discussed. I mean, this has to be an independent variable because if a stock has moved significantly in the pre-market session, then chances are high that it will move, that it will see some activity in the actual formal trading session. So this is my machine learning algorithm data, both the dependent and the independent variable. Then I fed this data to both my KNN and machine learning, KNN machine learning algorithm and the random forest algorithm. And this is the confusion matrix of both KNN and random forest. If you see, the both of them have similar kind of accuracy. They both do a very good job of identifying the bad stocks, which is like close to 90%. So close, like they identify almost 90% bad stocks correctly. But it's just that for good stocks, they have been, the accuracy has not been very good. It has been around 10%. But we must also acknowledge that I have kept the threshold as 1%. So there is chance that the stocks that they have predicted as good, but which turned out to be not to be good, may have a positive return, not more than 1%. So this is an area that I can do more research on, and this is something that I'll probably be looking in more detail to see, like uh, these 141 stocks out of this this 161 stocks that were predicted as good stock by the KNN algorithm, but which didn't come, but which were actually not good stocks. That means actually the return was less than 1%. What was the actual return? If they are positive, I'm still fine. I'm still happy with this return, with the performance of this algorithm. But if they're negative, then I have something to worry about. But as in whole, I was fairly encouraged by this result for both random forest and CM, because the it's doing a fairly good job of identifying the bad stocks, and okayish job of identifying the good stocks. So yeah, and all this was done. So now that the models were trained, these were then used to predict the good or bad stocks on out of sample data, which was like after the 4 months of data that I had used to train this model on. So this is the performance of my ML algorithms on the out of sample data, and if you can see, both of them have performed exceptionally well. Uh, the the backtesting period was only 3 weeks, because this is the data that I could get, the out of sample data that I could get to test my fitted algorithms on the out of sample data. But even in the 3 weeks period, you can see the return is pretty good. There have like the performance of the random forest classifier is volatile, is fairly volatile, but even the CAGR for this is fairly good. This is the KPI metrics of both ML and KNN. If you see, the KNN has a 54% CAGR, and random forest has a 51% CAGR. However, the drawdown of KNN is very very less compared to the random forest, which gives me which gives a fair indication that KNN was the most superior in all three, and the results are fairly encouraging. Even the win to loss ratio of 1.71 is pretty good. Um, this is a sample daily performance of stock screened using KNN for. So just to explain, on 13 December, the KNN predicted these four stocks as good stocks, and out of them, three performed really well. Uh, the performance of like for example this had a return of 2.5% on one day, 1.5% for second one, and close to 0.5% for the third one. One of the stocks had a negative return, but still very good day for the KNN predicted algorithm. Okay, so now that now that we have discussed that the results were fairly encouraging on the out of sample data, we also need to take into account the project limitations. Like I had explained earlier, because of the 5-minute intraday data requirement of the project, I had to use one of the paid services, and it only provided 4 months of data. Ideally, I would have liked more than 1 year of data because uh, in short terms, like the trends, like the market tend to see the trends. Market tend to maintain the trends. The trends are persistent over the short to medium term, and that can cause some bias in the trained classifier. So ideally, I would have liked 1 to 3 years of data, but I tried a lot. But getting 5-minute candles for that longer time horizon is very difficult. So I have decided to build an SQL database, and I've been saving this data to keep training on a longer time horizon data set and see how the performance changes. The second project limitation, like I said, was the limited time horizon for the out of sample data. So I started working on the project at the end of November 2018, and that's when I got the first cut of data, which is the past 4 months from 26th of November. And then for out of sample data, I had to wait till till 3 weeks when I was when I finished my project report, and then got my out of sample data cut from the same source. So since it was less than 1 month since the initiation of the project, I could only get 3 weeks of out of sample data. Again, this is a area that I am trying to get more data by using SQL database, by saving data every day, and then hopefully having enough data to have good enough uh, comfort in using both the training data time horizon and the out of sample time horizon for the 5-minute candles. The pre-market open data had some data quality issues. As I said, I got that data from web crawling, and there were many instances of the data being empty, so some of the data fields being empty or being invalid. So what I did was to get around this problem was to create a data bank wherein I saved the last valid value of each stock on each day, and then anytime there was an invalid value, I would access the static data library that I created and get the value from there. And every time there is a there is a new value, the static data dictionary gets updated. So this I was able to get around the stale data, the invalid data issue. But then again, if you're accessing the data dictionary, that means you're using stale data. So that was another problem which exists with this project. But just to qualify, the instances of stale data were not too many times. Like I would say, like less than 5% of the times is when I saw this issue of missing or invalid data. So yeah. And then the fourth limitation was like the amount of computing power that is required to train every iteration of the classifier or the machine learning classifiers, because even if it's even though it was just 4 months data, it was 5-minute granularity, so the number of rows were too many. And if and the process of optimization requires a lot of iterations to run the data, and then create the confusion matrix, and then see which hyperparameter was the most optimum. So just because of the computing power and time requirement, I was not able to optimize all the hyperparameters, although I did optimize the n value in the k nearest neighbor, which is very important to optimize. And also the random forest depth. So these are two things, two hyperparameters that I consider fairly critical based on my understanding on of these two classifiers, and I was able to optimize these hyperparameters, but not all of them. So yeah, we have reached the final stage of this presentation, and the conclusion is that although there were certain limitations in the methodology, mostly due to data issues, um, the results are very encouraging. My project does establish that ML algorithms can be used to do a much better job of screening stocks for momentum-based day traders. And I would encourage. I would definitely be using in my strategies, and I would also encourage further research in this area, um, because the result in the limited auto sample time frame was very encouraging. So that is my presentation. Thanks a lot, WorldQuant University, for giving me this opportunity, this excellent opportunity to learn about quantitative finance. I'm truly grateful to my instructors and to all the faculty members and my colleagues to uh, to to let me learn a lot in the past 2 years. So once again, thanks very much for this opportunity, and best of luck to to all my colleagues and instructors. Thanks a lot. Have a good day.